All right, so this is the first lesson in Chapter 5, which is working with fraction operations. Lesson 5-1 is finding the lowest common multiple. You'll see that this has some similarities to greatest common factor, but is actually kind of the opposite. So today's goals, students will be able to explain what the lowest common multiple of a number means, and students will be able to find the lowest common multiple of 2 or 3 numbers. First, let's start with a story problem. Sarah and Jane enter a walkathon for charity. They start together, but Sarah completes 1 lap every 6 minutes, while Jane completes a lap every 8 minutes. So the question is, after how many minutes will Sarah and Jane meet at the starting time again? So the first thing I want you to do is I want you to complete this table. So what is Sarah's time after she's completed 1 lap? Well, if she goes around every 6 minutes, then she will have done her first lap, and she will have crossed the finish line, or the starting line, at 6 minutes. Then she's going to go around again, and when she crosses that line again after lap 2, it will have been 12 minutes. So finish that up with Sarah. Then you're going to look at Jane. She runs around the track and completes a lap in 8 minutes. So lap 1 was done in 8 minutes. Then she goes around the track again, and it's another 8 minutes, so now she's ran for 16. Go ahead and finish both. Then figure out after how many minutes will Sarah and Jane be at the starting line and cross over it at the same time. Whereas with this lap, Sarah's going to go across it, and then Jane will be after. They won't cross at the same time. Then when will they meet again? So go ahead and pause and fill this in. All right, so here's your answers. Here's after how many minutes Sarah went around the track, and this is how many minutes she had run each time she crosses that starting line, and same with Jane. So when will they both cross together? Well, we have 6, 12, 18, 24, 8, 16, 24. I notice that at the 24-minute mark, they are both at the starting line. Then again, 30, 36, 42, 48, 32, 40, 48. At the 48-minute mark, they also are both at the starting line at the same time. This is what lowest common multiple is all about. It's going to be what's the first multiple of 6 and 8 that they have in common, which in this case would be 24. So let's talk about it a little bit more. Here's our warm-up. First, you need to understand what a multiple is. So a factor, let's just remember that a factor is what goes into the number. A multiple is the opposite. Now you're going to do 5 times 1, times 2, times 3, or count by 5s. So I want you to find the first 5 multiples of each number. This is in your packet. You have this slide. So I'll do the first one with you. 5 times 1 is 5. Then times 2 would be 10. Times 3, 15, 20, 25. So again, we're just doing times 1, times 2, times 3, times 4, or you can think of it as you're counting by 5s. These are multiples of 5. Remember, the factors of 5 would just be 1 and 5. So that's the difference between a factor of 5, 1 and 5, and these are the multiples of 5. Go ahead and try those 3. Pause the video and then check your work. All right, here's your answers, and I do apologize, this is slightly out of order from your packet. So if you haven't found this yet, this is just flip the page. It's on the next page, and then you'll just have to go back. So here's the first 5 multiples of each number. Fix it if you are incorrect. Remember, it's kind of the opposite of a factor. This is the multiples of 12 because we multiply by 2 and multiply by 3, 4, 5. And then if we did a T-chart, that would be the factors, what goes into 12. So just be really clear on the difference there. All right. So once you have this is also in your notes. We're going to use this list now to answer these questions. So when we want to know the lowest common multiple, we want to know what's the lowest multiple on each list that two numbers have in common. So let's do the LCM of 5 and 6. So we're going to look at our list of multiples of 5 and 6 and find what's the lowest number that they both have. Well, I'm going to count by, here's my shortcut strategy. I'm going to count by 6's, and I'm going to circle it when I know that 5 goes into that number also. So 6, nope, 5 doesn't go into 6, and I can check to be sure. 12, nope, 5 doesn't go into 12. 18, 5 doesn't go into 18. 5 doesn't go into 24, but oh, I know that 5 does go into 30, and sure enough, here it is as well. So the lowest multiple that 6 goes into and 5 is 30. All right, let's try 5 and 12. Again, my shortcut is I'm going to just look at the multiples of the larger number. So let's count by 12s until I know that 5 goes into that as well. So 12, nope, 5 doesn't go into 12. 24, no. 36, no. 48, no. 60, yes, that ends in a 5 or a 0. And if I kept doing my multiples of 5, I would eventually get up to 60. But because that could be a really long list, again, my shortcut is I'm going to just list the multiples of 12, and as I do, I'm just going to ask myself, does 5 go into that also? If I listed the multiples of 5, would I get to that number? And 60 is the first number that is true. So the LCM of 5 and 12 is 60. Let's try 6 and 12. Well, let's start with 12. The first multiple of 12 is 12, and so I asked myself, does 6 also go into 12? And sure enough, it does. So my very first multiple is actually the answer, and I can see that it is on the list of 6 also. Okay, why don't you try the next two? Pause your video and give those a try. All right, let's check your work. So I'm gonna start by listing the multiples of the larger number. That will save me time. 10 is my first one, and I just asked myself, does 5 go into 10? If I count by 5s, will I get to 10? And yes, so actually, I'm done. 5, 6, and 10. Here's what I did. Again, let's do a shortcut. Take your largest number. List the multiples of just that number, and just ask yourself, does 6 go into that, and does 5 go into that? So my first multiple is 10. 5 goes into 10, yes, but 6 doesn't, so let's keep going. 20. Yes, 5 goes into 20, but 6 doesn't. My next multiple would be 30. 5 goes into 30, and 6 goes into 30, so my lowest common multiple is 30. If I count by 5s, will I get to 30 eventually? Yes. If I count by 6s, I will also get to 30. All right, let's go back to that first page now. And you have a slide that looks like this. So let's take a little look at, again, why? Why do we care about GCF and LCM? How does it help us with fractions? When do we use them? So let's think back to last chapter where we found the greatest common factor of two numbers, like the greatest common factor of 25 and 40. Well, how did I use this? Well, I used this to simplify fractions. If I had the fraction 25 over 40, we now know that we have to always simplify. Okay, to simplify, what we did is we said, what's the largest number that I can divide 25 and 40 by? Well, that's the greatest common factor. And I would say that the largest number, or the greatest common factor of those two, would be 5. I can divide both of these by 5. 25 divided by 5 is 5, and 40 divided by 5 is 8. This is what we call simplest form. There are no more common factors of 5 and 8 that I can divide them by. So that's why we needed GCF to help us with fractions. So, and make sure, by the way, that you have that all copied. If you need to pause, go ahead and do that. Well, now we're talking about lowest common multiple. So why do we need this for fractions? Well, the opposite of GCF is lowest common multiple. That is the lowest multiple that two numbers have in common. So it really does make a lot of sense. So let's say that I have two fractions, 1/4 and 3, let's say 3/5. and we want to add those two fractions together. Well, we already know that because we have different denominators, we cannot add those two fractions right now. So what we have to do, and we'll learn more about this later, is create a same denominator. Now to make that easy, we want to pick a denominator that I can do 4 times something equals that and 5 times something, or we want a multiple of 4 and 5 that they have in common. So what's the smallest number that's a multiple of 4 and 5? Well, let's see. 5, nope. 10, no. 15, nope. 4 doesn't go into that. 20, yes. 20 is the first number that 4 and 5 can multiply into. So we're going to choose 20. Okay, so then I can create my equal fractions by saying, how do I get from 4 to 20? I do times 5, so we have to do the top times 5. 1/4 equals 5/20. Now how do I get from 5 to 20? Times 4, so we do the top times 4. 3/5 is equal to 12/20. Now that I have like denominators, now I can add. 5/20 plus 12/20 is 17/20. So again, we will talk more about how to add fractions later, but I just wanted you to see why lowest common multiple is important, because we have to create like denominators before we can add or subtract. All right, let's go to the last page of your notes and we'll wrap this up. Let's see what's happening when we do LCM. When we do multiples of 4, I said we're counting by 4s. So let's show that on the graph. Let's count by 4s and go 4. Now we're going to skip 4 each time. Then we'll land on 8, then 12, then 16, and then 20. So we just counted by 4s on our number line. Let's pick a different color and let's count by 5s. So we would go to 5, then 10, then 15, and 20. Notice what happens at 20. That's the first time that 4 counting by 4s and counting by 5s gets us to the same number. And this is our LCM. It's the lowest common multiple. It's when they first meet each other. And again, we already talked about how does this help us. We can change both fractions to 20ths, times 4 times 4, times 5 times 5. Now, since we have like denominators, we can add and see that our answer is 19/20. So there you go. So you can go ahead and stop and begin your practice problems, or you can do those tomorrow and just do a little computer practice tonight. Thanks.